Thank you very much. I just want to say, yeah, what a day, what many amazing talks. And this one I think is going to be a bit more chill, more relaxed, like the end of the day. Also a bit, yeah, easygoing. So, yeah, what is the problem? This is actually like these two sites. I just got it from last week's zk hackathon. And it makes it, just mainly says that still like proving or deploying proving code basically on production services is actually still challenging or very time consuming. And this is something that it has been like rubbing my mind for quite a while, because I mean, in the end, if you look at it from, I'm a developer at core, I have to say, so if you look at it, it is basically what you want as a developer. You want to give the arguments, and then you want to get like the proof back in the end. So there has been like today already like many times been talk about like there's like DSLs, like Silicon, for example. There is a good way to how to like optimize and create circuits, but like when you use these DSL solutions, basically, they're kind of like leave you hanging when it comes to actually deploying these circuits. So you're very good. You do like the setup, you optimize, you can verify easily on the blockchain, but like, what do you do? Like, how do you put this into like the production? So yeah, normally what these solutions just say, it just say like write a JSON, a JavaScript application basically, which, you know, if you're working on the browser, makes sense. So I'm not saying this is not like a hate talk about JavaScript or anything like that, but for if you're wanting to prove like on a server or something like that, this is actually probably not the best way to do it, basically. So I'm just gonna go and so yeah, as you can see, this is me, the blonde person here. So you might ask like, who am I? So I started to play with zk-SNARKs back in 2019. I thought I would program the ultimate voting app, very original. And that's how I started to play first with Socrates, and then with you know, Circom, and finally now I'm starting my PhD, and like these are like three of my interests basically. So I'm looking basically on the intersection, hopefully, to do my PhD. So yeah, like from the beginning on, like I feel that kind of like that pain, because back in the day also like there was no Poseidon hash, or at least like no implementation, anything. So everything would took forever, and yeah, then proving kind of like, or deploying basically the circuits turned out to be way more challenging than what I expected. So let me go on to see like how kind of, you know, like a proving app would look in a server basically when you use like these DSLs basically. So you have the API probably that communicates with other services basically. Then I say put it here, rollup is basically just an example of an application logic basically that you want to, so that this is actually where the business logic is, and like below that then you have like something where you want to like, where you want to translate to like a zero knowledge. And on the top you would see like, we will have kind of like the database for the basically application logic, and then you will have the secrets and the proving key all together. So fair enough, you know, so now, you know, because we've seen today also like how many promising applications there is for zero knowledge, you want to do that for another application. So you kind of end up doing exactly basically the same thing, but just with another one. Like here, like there's a bridge, another application. So yeah, we kind of like do a lot of things all over again and all over again. And it's also like, also in a way that it's kind of like not necessary, because, you know, these things are at least kind of like, you can think of like abstracting these things away, no? So for that, I kind of like think of it as a developer kind of in a service approach, so to say, where instead of having kind of like a monolithic app, you kind of have like your app, and if you want to prove something, you kind of like send it to the proof service, basically, with the arguments, and you get the proof back, basically. And yeah, this is I think kind of like it makes more sense because first of all, you just like prove your proving service. You program it once, and you don't need to like program it every now and then, like all the time, maintain so many like components on different apps. You just have it once, and if you need to change something, you change it in one place and not in 1,000 ones. Yeah, and you can have like basically many. Yeah, you can have like you can use it for different things. Also, like normally people think like, okay, so I just want to have a rollup, so I have one circuit. But if you see many of the rollups implementations, there are actually many proofs. You want to register, you want to do your register. So you're not using just like one proof, but you're actually like many. So having just also like a service here, it would just like, you can do that without kind of like compromising or incrementing the complexity of the rollup basically. It's also reusable in the sense of like another service can use it. It's kind of like the point that I used before, basically. So yeah, like I want to have a rollup service, I want to have a bridge, but I only need just like a proven service in which I have like both of them are stored. And that's also one of the good things about DSLs is like that you store the circuits in disk and not in memory compared to libraries. And this is actually might seem like a small detail, but in terms of zk-SNARKs, like these circuits are big files. So you're like actually, memory is something very precious. Another thing, and this is also like, this is probably before was not so important, you can duplicate it basically. You can like think about like these stacks basically, or these cans as containers. You could use something like Kubernetes and duplicate, actually scale it horizontally very easily, or even like scale it vertically, just put the container in a bigger machine without not having to do much for it. And this is, for example, something that nowadays probably might be like even very interesting if you kind of like take into account folding schemes or recursion, where you are in some cases also able to compute things in parallel. So you would actually actually be able, with the new kind of folding schemes, kind of like microservice the zk-SNARK proving. And for that you kind of need like also tools where you just can deploy anywhere basically, and you can just like boot up or boot down as you wish. So I think like this service approach gives you quite a lot of like flexibility. And lastly, which it's also not so important, is also it's technology agnostic, in a sense of like before that, if you wanted to use like a DSL, basically you were saying like write JavaScript. But what about if like your client or your service consumer, it's written in Go? Why do you have to like kind of like choose JavaScript just because you want to prove? So here you actually have like the flexibility on both sides. You can choose the technology that perform the best when it comes to proving, and then you can have the technology that works the best for your business logic, basically. So yeah, to wrap it up, if I just wanted to make sure, so this presentation was not about like hating on JavaScript, although, I mean, you can see it's me, but like, this is actually not my my message. It's not about like that JavaScript is bad, or like the libraries that the DSLs are offering are bad, but it's just like what I feel like it's just like the point, it's completely the wrong point. It's not about which programming language you should use to prove, but whether like what kind of thing like gives you like is the best, basically. And in this case, improving, you just want to have like something just like that works fast, basically, because it's also like something very energy consuming. So yeah, like when we have like, and also like the point of having this kind of like proving service is not that everyone now creates its own proving service, but rather if you have like your own proving service that is working fine and so on, just like build it and push it to like an image registry. So anyone basically can just like pull it and also not have to think about this kind of pains, like just get your circuits optimized with circom, which is like a great library, and then make just like a circom proving service, which is very good at generating proofs from circum circuits. So yeah, this is kind of like the summary basically of my presentation. It's just like kind of like maybe to expand the concept of like what kind of like tools you have basically when you're using DSLs to when it comes to proving. So these two ones basically, the CLI and the JS libraries, actually it's kind of like are the tools that almost every DSL are providing. Circom, Socrates, Noir, almost like all of them that I've checked, at least like they all of them follow that pattern. But as you can see, like they're good definitely in some things, but they're not good in certain type of like uncertain scenarios. And at the moment, there's actually kind of like a hole or like a gap that like nothing is filling it. And my point would be that actually a service basically is something that is like fulfills this gap. So yeah, that's actually it for me. So if you want to like implement your own proving service, so for example, I did that with Socrates like 2 years ago, and it worked very well. With Circom, I haven't come to get into the time to implement that, but if you're also interested in so, just tell me and maybe we can just like do it together. Or if not, just look out for my Circom image maybe in the near future. Thank you.
Thank you, Alvaro. So questions, what questions do we have? So I'm gonna break the ice with one. So how do you see this happening with private applications where you might not want to send data to the server? Or do you think this is best for other type of ZK proving applications?
I mean, there are some, it's a good question. I mean, this is originally think for like basically as a developer tool, basically. So you want to prove and you have like your own architecture. So exactly, basically the arguments basically don't leave your private network, so to say. But I mean, there are there's some papers that actually kind of like tackle this thing in the area of collaborative zk-SNARKs, where they kind of create protocols where the witness remains private. Exactly like also for the purpose of you kind of like offload the proving basically to some cloud provider. This is something that I intend to like go into like on my PhD. So I just like started like 2 months ago. Yeah, so this is something still on there. Yeah, but so at least for now, I wouldn't recommend it. If you're like, if there's some private concerns, exactly, just like probably this is not the use case in this topic.
Thank you, great answer. And there we have another question over there.
When we use the backend as a proving service as a backend, then maybe I think there will not be that much frequently requested the generating proofs, but we need to prepare all the instances, and it's kind of expensive. So how do you handle that kind of problem?
How do you prepare the arguments, you mean?
No. Actually, it's from our consideration. When we make our ZK fault proof, it usually does not happen usually, but we need to prepare all the instances. So our solution was that we just make simple proxy server, and if we need to generate proof, then the proxy server get the request, and then the proxy server create instance for proving for generator proof.
Okay.
Yeah.
This,
yeah.
okay, because see now I see your point. So this is actually the proof is not happening too often. So it doesn't make sense to yeah, then definitely probably like a service doesn't make sense because you have something open too much. I would say maybe they're like some like function, like cloud function. You probably could, let's say, in AWS or Google Cloud, pull the Circom, no wait, or like a SNARK.js image, and just maybe run there like the proof basically. So you pay every time you, for example, you use it. That one I would say like my guess in that case. Yeah, like here, for example, I assume like you're constantly like running proofs, for example, or you maybe like this probably, I think it's a good idea when you have actually, you're running multiple applications which need zk, you know, which I think it's kind of like, at least what we hope in the future, this is something that is kind of like standard, that everyone needs zero knowledge proofs.
Thank you.
Any other ones? All right. Round of applause. Thank you so much.